Dear students, our next topic is floating point numbers. In the decimal system, very large and very small numbers are expressed in scientific notation by stating a number and an exponent of 10. That is, you don't confuse with the theories. That is, for example, 6.53 into 10 raised to minus 27. This is called Mantissa. That is this Mantissa, and this is called the exponent. Another example, just 1.58 is the exponent, Mantissa, and 10 raised to 21 is the exponent. That is, when compared to the theory, very large and very small numbers are expressed in scientific notation. That is, we from this figure we can see that this 6.53 in 10 raised to minus 1 is a very large number. This is also a very large number. So this is expressed in this form, that is the Mantissa and exponential form. Likewise, the binary numbers can also be expressed in the same notation by stating a number and an exponent of 2. That is in this case a Mantissa and exponent. In this machine, a 16-bit word, a 10-bit Mantissa and a 16-bit exponent. That is, in this case, this is a 16-bit, this is a 10-bit word, and this is a 16-bit exponent. The total is 16-bit. This 16-bit can be expressed in a 10-bit Mantissa and a 16-bit exponent in the binary case. That is some rules for the floating point number representation. The equation is plus or minus significant into base raised to plus or minus exponent. That is, for example, you just see this example, that is 0.000 up to 5. Then we termed as that is 0.5. This is just 0.5 into 10 raised to minus 10. Same case, that is 5 and up to 10 zeros. 5 and up to 10 zeros. Then we write it as 5 into 10 raised to 10. That is you studied about this equation, that is plus or minus significant into base plus or minus exponent. Then write the two examples. Then the normalization rule of floating point numbers. The integer part should be 0. Then we have to go to the examples. The normalization rule, the integer part should be 0, and 0.d1, d2, d3 up to dn into b raised to plus or minus exponent, then d1 greater than or equal to 0. This is a two normalized rule for the floating point numbers. That means, just compared with the example, that is, in this case, here the integer part must be 0. The integer part must be 0 means just these three numbers. In the integer part, this is 0, this is 0, and this is 1. So this is a wrong. Again, the second rule, 0.d1, d2 up to dn. That is, this d1 greater than 0. In this case, the d1 means this is only this one make greater than 0, and this is 0. So this is also wrong. This is all about the floating point numbers.